Hi guys, this is Miss Gold. Today's lesson is Module 3, Lesson 3, using the identity and inverse to write equivalent expressions. Your outcomes for today's lesson are students recognize the identity properties of 0 and 1 and the existence of inverses, which are opposites and reciprocals, to write equivalent expressions. The first thing I'd like you to do is pause the video and complete the opening exercise. Unpause the video when you're ready to continue. So take a minute to look over your answers to the opening exercise. These are all fairly basic questions. You shouldn't have any trouble answering them. And you'll notice that there are some patterns going on here. In the first two questions, we have a series of opposite numbers or opposite variables. And all of these add up to 0. So this group of questions is really showing you the additive inverse. And that idea is really verified in question 3, where the pattern that you should have found in 1 and 2 is the sum of additive inverses always equals 0. The questions within number 4 are really showing you what's called the additive identity. And again, the pattern that you should notice is that the sum of any quantity in 0 is always going to give you the original quantity back. Start with example 1. It says write the sum and then write an equivalent expression by collecting like terms and removing parentheses. Part A wants us to write the sum of 2x and negative 2x plus 3. So I'm going to start with my 2x. Sum means to add. And because this has two terms in it, I'm going to group them together in a set of parentheses. Now, what I want you to get in the habit of thinking is, similar to what we talked about in the previous lesson, when you have parentheses, you should think distributive property. And in the previous lesson, we saw an example where we had a subtraction sign and we viewed that as multiplying by negative 1. Well, here we're multiplying by positive 1. So if you think about it, we already know that if you multiply things by a positive 1, that is really going to be the multiplicative identity. So that's going to give us the same result out. So what this really does is this takes away the parentheses for us, giving us 2x plus a negative 2x plus 3. Now in this case, I can see that these are like terms, so we can use the associative property to group these two together. And then we know that these are additive inverses. So from our previous examples, we know that they're going to add up to 0. So this really gives us 0 plus 3. And any number, as we learned in the previous example as well, any number plus 0 is going to give us that number. So our final answer here is 3. Let's just note some of the properties that were used here. So first we use the distributive property. Here, we use the associative to group them together. And then we used the additive inverse to get the 0. And finally, we use the additive identity to get our final answer. Part B wants us to find the sum of 2x minus 7 and the opposite of 2x. So let's start to translate this. First of all, I have two terms in this, so I'm going to group it in parentheses. 2x minus 7. We're finding the sum, so that's addition, of the opposite of 2x. So the opposite of 2x is going to be negative 2x. So again, if I see more than one term in parentheses, that's distributive, so let's put our invisible 1 there and multiply that in, will give us the same thing out. So we have 2x minus 7 plus a negative 2x. So I can use the commutative property here to switch these two terms, giving us 2x plus a negative 2x minus 7. From there, I can group together my two x's. 2x minus 2x, those are additive inverses of each other, giving us 0. And drop down our minus 7. 0 minus 7 is negative 7. Part C says the opposite of 5x minus 1 and 5x. So again, we're writing the sum, so we're going to add together. However, we need to take the opposite of 5x minus 1. So the opposite implies a negative, and then we'll group together the 5x minus 1 in parentheses, added to 5x. Now the first thing I need to do here is to distribute the invisible negative 1 here. That will give me the opposite of both 5x and negative 1, giving us negative 5x, a positive 1, and a positive 5x over here. This one doesn't change because it's not inside the parentheses. Then I want to use commutative property to switch these two so I can group together my 5x's. Negative 5x and 5x are additive inverses, so we get 0 plus 1. And 0 plus 1 is the additive identity, giving us 1. For example 2, we're going to turn our attention to multiplication. So let's go through each one of these examples. Here we have 3/4 times 4/3. Now, typically what we know to do is to multiply across the top and multiply across the bottom with fractions. So let's show that, but not actually show the result, because I want to show you that there is some ways that we could simplify these. So we could have 3 times 4 on the top and 4 times 3 on the bottom. And what you should notice here is that when we have a 4 on the top, 4 on the bottom, those cancel to become 1 because 4 divided by 4 is 1. And the same thing happens with the 3. 3 divided by 3 is also 1. So all of these are going to cancel and become 1 over 1. And 1 divided by 1 is 1. So we could do the same type of thing with each one of these here. We can put our 4 in over a 1. So really what I'm doing is doing 4 times 1 and 1 times 4. Again, 4 on the top, 4 on the bottom cancels. We're left with 1 over 1, which is 1. 1/9 times 9. I'm going to turn the 9 into a fraction by putting it over 1. And our 9s will cancel. And so I'm left with 1 divided by 1, which again is 1. So you can see we're really seeing the same thing over and over again here. Same thing with the last two. It's just going to involve some signs. So here we have 3's will cancel, giving us 1 on the top, 1 on the bottom. And then a bad guy leaving town is a good thing, so that is going to be a positive. 1 divided by 1 is 1. Same thing with the last one. Our 6's can cancel to become 1, our 5's can cancel to become 1, and a bad guy leaving town is a good thing, leaving us with, again, 1 over 1 is 1. So what we're actually seeing here is the two numbers that are being multiplied are inverses of each other. Really, when it's a multiplicative inverse, it is known as the reciprocal. So we can see that when you multiply a number by its reciprocal, you will always get the multiplicative identity of 1. So all of these are showing multiplicative inverse, inverses equal 1. So we are asked to write the product and then write the expression in standard form by removing the parentheses and combining like terms and to justify each step. In the first part A, it says to multiply the multiplicative inverse of 1/5. So if I'm going to take the multiplicative inverse of 1/5, it's actually asking me to take the reciprocal. So the reciprocal of 1/5 is 5 over 1, and 5 divided by 1 is 5. We are multiplying that by 2x minus 1/5. So here we need to do the distributive property. That's going to give me 5 times 2x, then 5 times negative 1/5. So here 5 times 2x gives us 10x. And here we have a good guy leaving town is a bad thing. And here I can actually turn the 5 into a fraction by making it over 1. And we can see that these are multiplicative inverses. So that is going to give us 1. So again, justifying each step, we basically did the distributive property here. And here we used multiplicative inverse. Part B says to take the multiplicative inverse of 2. So again, I'm going to turn 2 into a fraction by putting it over 1, and then the inverse really means the reciprocal, so I'm going to flip these two. So this becomes 1/2 multiplied by 2x plus 4. So again, we're going to use the distributive property multiplying this in. So this is going to be 1/2 times 2x plus 4 times 1/2. So here we can see that these are actually multiplicative inverses. So these two are going to cancel and become 1, leaving us with just x. And half of 4 gives us 2. So we use the same kind of properties there, the distributive property and the multiplicative inverse. Part C says to multiply the multiplicative inverse of 1 over 3x plus 5. So this is just saying to take the reciprocal of this, which is 3x plus 5. Now because there's two terms there, I'm going to keep it grouped in parentheses. And we're multiplying this by 1/3. If you're not comfortable in this form, you can use the commutative property to switch them. So we have 3x plus 5. So again, we're going to distribute. This is going to give us 1/3 times 3. If we cut out that step in between like we had here, we know that 1/3 times 3, these are multiplicative inverses of each other, giving us just 1. And so this will leave us with 1 times x, which is x. And 1/3 times 5, we would have 5 on the top times 1, which is 5. And 3 times what we turn this into a fraction, 3 times 1 will give us 3. So we get x plus 5/3. So in this lesson, you learned how to simplify expressions using different properties such as the commutative property of multiplication or addition, the commutative property of multiplication or addition, the distributive property, the associative property of addition or multiplication, the additive inverse, the additive identity, the multiplicative inverse, and the multiplicative identity. All properties that we've seen before, but we're getting some more practice with how to use them and simplify, which will lead us into eventually simplifying before we solve equations.